Okay, today I'm going to show how to use the APT calibrator to calibrate the K factors and the AP series. So firstly, we open the APT calibrator here. So now you can see there are two windows. So one window is pole simulator. We did this calibration and simulation before, so you can find in another video to see the details. So here we need to calibrate the key factors. So the method is firstly, so we see here, so we input the image compression factor. So now, so you see this window here, then we click Reconstruction Explorer. So now we enter into this. So now we can pick a pole to calibrate KF. So so here you can see 101 or 100 is good candidate to calibrate. So we use 101 pole here. So firstly, we need to know the location of this pole. So this is minus 14 and minus 14. Okay, so so then we input here minus 14, minus 14, and input 3 in as out radius. Okay, so now we also input the coordinate or XY projection, same as the value here. So now, okay, let's check. So okay, then the next job is to input the initial tip radius. So here is the initial tip radius. Okay, so since we select 110 pole, so actually we should use 220 pole to calibrate, because this one has a smaller interplanar spacing. So actually 220 and 110, they are at the same location, but 220 will have a small interplanar spacing, so we actually use this to calibrate. You will know the reason later. So here now we input tip radius, and so actually okay, so then we can try to generate the spatial distribution map. So now you can see, actually you cannot see the peak here, so we can change to another radius, maybe 30 here. Okay, so now we begin to see some planes, crystal planes here. So we click generate again. So now you can see here the this peak, the distance between the zero peak and this peak is actually the interplanar distance. So now if we select this area, we can know the value. So then we change to 30. Okay, so 220, and also so this value actually is observed distance between the crystal planes. So now we have 0.21 as crystal planes. So then we can calibrate the tip radius. Okay, so now we get the value here. Okay, so we input here. Okay. Then generate another spatial distribution map. So now you can see this peak is closer than the previous one. Now it's close to it's close to the theoretic distance. So we can do a further calibration. So another iteration here. So now we get 35.9. Okay, 35.9. So generate another spatial distribution map here. So then now you can find it's really close to 0.143. Okay. Now we finish this calibration. So click OK. Okay. Now you can see here we should calibrate the KF. So and you can see here is the KF number. So how we use this? So firstly, we change this number, maybe just fine. You can select any number here. So now you can get a new tip radius. So actually it will reveal the relationship between KF and the initial tip radius. So we just input here. Then it will calibrate tip radius and the KF. So and give a new KF here. So if you click here, then we get a new number. So if we copy this new number to here, then we get a tip radius, and you can compare to the tip radius after calibration. You can see this number, and just it is exactly this number. So now we actually finish the KF calibration.